In the year 1960, two men descended to a depth of 35,814 feet, which is about 10,916 meters, below the surface of the Pacific Ocean. They stayed there for 20 minutes. During those 20 minutes, they saw a flatfish moving along the seafloor. That observation has never been fully explained. Since then, scientists have returned to the Mariana Trench 22 times. That fish was never recorded again. This is the Mariana Trench. And here is what it has left unexplained. You are currently sitting about 6.8 miles, or roughly 10.9 kilometers, above one of the least understood places on Earth. Its coordinates are 11 degrees 21 minutes north, 142 degrees 12 minutes east. Located in the western Pacific Ocean, 200 miles, which is about 322 kilometers southwest of Guam. The name of its deepest point is Challenger Deep, below 36,000 feet, or about 10,972 meters. Three physical conditions apply simultaneously, and there are absolutely no exceptions. First, the pressure here reaches 1,086 atmospheres. To picture that number, imagine putting 50 jumbo jets on the tip of your thumb. That is the force pressing down on every square inch, which is roughly 6.4 square centimeters, at the bottom of this trench. Second, the temperature ranges from 34 to 39 degrees Fahrenheit, or about 1 to 4 degrees Celsius. Water does not freeze here, not because it is warm, but because the pressure simply does not allow it to happen. Third, there is no light, none at all. Not a single photon from the sun can reach this depth. It was completely absorbed from 3,300 feet, which is about 1,006 meters, and above over 6 miles, or roughly 9.6 kilometers away. Below 36,000 feet, which is about 10,972 meters, the rules change. What most people believe about the Mariana Trench is this: it is empty. It is too deep, too cold. There is too much pressure for anything complex to survive. The data does not support this. In 1960, Jacques Piccard and Don Walsh were the first to descend into Challenger Deep. Their equipment recorded shrimp and flatfish behaving normally at a depth where, theoretically, complex life should not exist. They reported this. The scientific community was largely skeptical. In 2012, James Cameron made a solo dive down to 35,787 feet, or roughly 10,908 meters. His cameras captured amphipods, which are tiny crustaceans, swimming in swarms. He also documented polychaete worms and single-celled organisms large enough to be seen with the naked eye. The footage was verified. The skepticism began to shrink. In 2019, Victor Vescovo set a new record when he descended to 35,853 feet, which is about 10,928 meters. He recorded living creatures. He also recorded something else. A plastic bag and candy wrappers. Human materials reached the deepest place on Earth before humans even made their second trip down there. This trench is not empty. What it contains is still being categorized. What has actually been recorded is this. In 2017, a camera trap from the National Oceanic and Atmospheric Administration, set at a depth of 26,831 feet, or roughly 8,178 meters, captured footage of a swimming creature. It was active, not paralyzed, and not deformed. It was the Mariana snailfish, Pseudoliparus swire. It should not be able to do that. The first problem is bone. The bones of all fish are reinforced with calcium phosphate, which is a rigid structure under normal conditions. At a pressure of 1,000 atmospheres, calcium phosphate is crushed into dust. The bone structure of the snailfish solved this problem by not being bone in the traditional sense. Its skeleton is semi-liquid. It is flexible. It bends with the pressure instead of fighting against it. The second problem is protein. The proteins of all known living things begin to deform and collapse at depths exceeding 25,000 feet, which is about 7,620 meters. Their molecular structures simply cannot withstand that level of compressive force. The snailfish uses a chemical compound called trimethylamine oxide to fight this at a molecular level. The concentration of this compound in its tissue increases linearly with depth. The deeper it goes, the higher the concentration. But there is a limit. At a certain depth, the concentration of trimethylamine oxide needed to counteract the pressure would be so high that it would actually collapse the animal's cells from the inside. That limit has not been experimentally confirmed, but calculations suggest it exists somewhere between 27,000 and 30,000 feet, or about 8,230 to 9,144 meters. The snailfish has been recorded at 26,831 feet, which is roughly 8,178 meters. Its behavior below 30,000 feet, or about 9,144 meters, has never been directly observed. The snailfish is the most documented creature at this depth. What is recorded below it is much less certain. The question is this: phytoplankton, the very first energy source of every food chain in the ocean, ceases to exist at about 600 feet, which is roughly 183 meters. That is the boundary where sunlight disappears. Without light, there is no photosynthesis. Without photosynthesis, there is no primary production. From 600 feet, which is about 183 meters, down to 36,000 feet, or roughly 10,972 meters, there is no self-generated energy source. So, what is the ecosystem at the bottom of the Mariana Trench eating? The answer is partly marine snow. Dead organisms, feces, and organic matter from the surface layer fall continuously like snow in the dark. The rate of descent is about 328 to 492 feet per day, which is about 100 to 150 meters per day. To reach Challenger Deep, a single flake of marine snow takes about 240 days. During those 240 days, bacteria and intermediate organisms have already broken down 98% of its nutritional value. What reaches the bottom is not food by any measurable standard. Yet the creatures down there are still surviving on it. But there is another source. It has been documented. It is infrequent. But when it happens, it changes everything at the bottom for decades. When a whale dies and sinks to the ocean floor, it creates what scientists call a whale fall, a temporary oasis of nutrients. A 44 U.S. ton whale, which is about 40 metric tons, provides the equivalent energy of 2,000 years of normal marine snow, all in the exact same spot. Amphipods found in the Mariana Trench have lipids from whale bones inside their tissues. This confirms that they are consuming whale falls that happen thousands of miles up on the surface, and then those carcasses gradually make their way down. The consequences of this are still being measured. And there is one more thing. In 2016, the National Oceanic and Atmospheric Administration discovered signs of a chemosynthetic community in the Mariana. These are bacteria that use hydrogen sulfide from geothermal vents to generate energy, completely replacing sunlight in the food chain. If this is confirmed on a large scale, the Mariana Trench has an ecosystem that is entirely independent of the sun. That survey covered just 0.3% of the trench floor area. In 1997, the hydrophone system of the National Oceanic and Atmospheric Administration recorded an extremely low-frequency sound coming from a point in the South Pacific, about 1,500 miles, or roughly 2,414 kilometers, away from the Mariana Trench. The sound was loud enough to be detected by sensors 3,000 miles, which is about 4,828 kilometers away. It lasted for about 1 minute. Its frequency profile matched the characteristics of a biological source, something that is alive. There is no known animal that can produce a sound on that scale. In 2005, the National Oceanic and Atmospheric Administration reclassified the origin of this sound as an icequake, a massive iceberg in Antarctica breaking apart. This reclassification is widely accepted within the scientific community. The frequency match with biological characteristics has not been fully explained within that framework. As of this recording, the file remains open. The Mariana Trench spans 1,580 square miles, which is about 4,092 square kilometers. As of 2024, less than 1% of its bottom area has been directly observed. File under Hadal Zone Unsolved. Next file. What deep-sea creatures actually become below 6,000 feet, which is about 1,829 meters.